Okay, morning class. Welcome back.
Morning, hi.
Okay, so welcome back to the class. Where's my pen? My pen. Okay. Okay, so can you see my screen?
Can, doctor.
Okay, good. Okay, thank you. Right, so you do you guys still remember what we went through last week? So parametric equations, right? So I hope you still remember the important features of a parametric equation. Okay. So for today, what we're going to do is we are going to just go through a few more examples. Okay. Just so that you can familiarize yourself. Okay. With this thing called parametric equation. All right. So where did we stop? Where did we stop? Well, we stopped with the one with the infinity. We stopped the one with infinity. Okay. All right. So we are going to go through a few more examples, okay, regarding parametric equations today. Oh, don't do that. How to scroll? Okay. Suddenly I cannot scroll. Wait. Suddenly I cannot scroll the screen flat. I can only zoom in and out. Okay, all right. So let's go through one more example. Okay, so let me know, yeah. So let me know if you during the class, if you cannot see what I'm writing clearly, or if you cannot hear me, just let me know. I will try to turn the volume up or something. All right. Okay. So next example. Let's say I give you another two equations. X equals to t. We are going to just very quickly skim through this one. This one's very similar to the previous example, which we stopped at last week. All right. So if x equals to t, y equals to t squared. And the interval is negative infinity to infinity. Can you plot the function show direction with the initial point and the terminal point? Okay, so it's asking for four things here. All right, show the function. Sorry, plot the function. Next, show the direction. Next, show me where the initial point is, and show me where the terminal point is. Okay, so normally in any parametric equation questions, it's going to ask for these four things. You must make sure all four items is in your answer. Okay, otherwise if any of them is missing, you're going to lose marks. All right. Okay, so for this one, we are so from last week, I think you can probably tell there are two ways. There are two ways of solving this problem. We have the first method. I'm gonna show you the first method first. Okay. Okay, so we have first method. So the first method is you have to what does the first method do? Well, what's one way you can use to solve this problem? You can convert the parametric equation to a normal, to a Cartesian function. Okay, so this is method one. You convert the parametric equation to a Cartesian function. So what that means is your x equals to t, your y equals to what? T squared. Yeah, t squared. You combine these two so that you only end up with x and y and no more t. Okay, that's the first method. Okay, so you combine these two into a function that consists of only x and y and no more t. Okay, and you only have one function. Okay, from two functions you go to one function. So let's tackle this method first. Okay, so how are you gonna do this? Well, this one's easy. X equals to t, y equals to t squared. Can you substitute so y is equals to t squared? Can you substitute x equals to t in there? So you end up with y equals to what? So if I replace the t, yeah, x apa?
X squared.
Yeah, good. Thank you. Good. Okay, there, finish. Okay, so this one is simple, but obviously in test and exam it's a bit it won't be this simple lah. Yeah, this one's just a simple example. Okay. Okay, so there we've done it. We've converted the parametric equations into a normal into a Cartesian function. Okay. So next we plot. How do we plot? Well, this one's simple. Again, this one's simple. What is x? What is y equals to x squared? Well, from memory, you know, or rather, you should know. Y is equals to x squared is this. Okay, it's a u. All right. Now, what is the interval? So the problem is with the interval is it goes from negative infinity to positive infinity. All right. So if it's negative infinity, what's gonna be your so basically there's no starting point. Okay, it's infinity. So your starting point is somewhere there. Your terminal point is somewhere there. So your direction is this. Okay, but because it's infinity, your starting point is somewhere there. Your terminal point is somewhere there. Okay, but it basically keeps continuing because, like I said, it's infinity. All right. Now the second method. The second method is by drawing your table. It's by drawing your table. You have t, and then you can calculate your x and you can calculate your y. All right. So basically, you try with all the different possibilities to get x and y. So we can try, well, t. T is your is this kind, it's your interval. All right. So it goes from negative infinity to some infinity, positive infinity. Okay. So you can try negative infinity. What's a good negative infinity number? Now let's say negative 1000. Okay. So you're gonna get an x and y value. I don't know how much you can calculate. Okay. And then maybe negative 750, and then maybe negative 500, then maybe 0, then maybe 500, then maybe 750, then maybe 1000. Okay. So you keep plotting a lot of numbers in this table. So once you've got the numbers, then you can plot according to the x and y. You will get the same shape, basically. Okay, you will get the same shape, basically. Okay. So that's one example. So let's go through another example, a more realistic one. Okay, that one, the previous one, is a little bit simple. Okay, so this one's a bit more realistic. Okay, so x equals to a cos theta, y equals to a sine theta. So in this example, your parameter, so the parameter is normally t. Okay, so parameter is normally t, but in certain cases, I can make the parameter something else. Okay, it doesn't necessarily have to be t. Okay, so in this case, the parameter is theta. Okay, while a can be any positive number. Okay. So let's say the interval goes from 0 to pi. Okay. So in this question, the parameter is theta. That means the t is theta. Okay. Now this a is just a common variable. You don't have to worry about the a. Okay. A is any number that is bigger than 0. Okay. So you can just assume a is any random number that is bigger than 0. Can be 1, can be 2, can be 3. Doesn't matter. Okay. You don't worry too much about it. A. Okay. So same thing with this question. Want you to plot the function. Show direction. Show where the initial point and the terminal points are. Okay. Okay. So, right. Okay. So how do you do this? So for this one, I'm gonna. So again, you have two methods. Yeah, just like the previous question, you can use either method, 1 or 2, doesn't matter. But in this case, I'm gonna use method 1 because I think it's gonna be faster. Okay. So let's use Let's convert. I'm going to use the conversion method. Let's convert to Cartesian function. Okay, I'm going to use the conversion method. Right. So from the question, we know x is equals to a cos theta. We know y is equals to a sine theta. Okay. So how do we count? So the aim here is when you convert, the aim is always to combine both x and y equations into one equation that consists of only x and y. Okay, so no more theta in this case. Okay, so that's the aim when you do the conversion. Okay, you want to convert both so that you are left with only x and y and no more theta. Okay, now you can still have the a. You can still have the a because the a is just a random number. Okay, it's not even a variable. It's just a random integer. All right. Okay. So how do you convert? How do you combine both so that you lose the theta? All right. So you can rearrange. So we know x is equals to a cos theta. So I can rearrange to get cos theta. Yeah. So yeah. So if you rearrange this, you're gonna get cos theta equals to x array. Next, we know y is equals to a sine theta. You rearrange to get sine theta, you're gonna get y over a. Okay. So now we can merge both together. Making sure we remove that common parameter theta. Okay. How do you okay, so in the previous method, the way I merge the two is I just substitute one into the other. Yeah, I substitute one of the equations into the other. But in this case, you can't. Yeah, there's nothing to substitute. You cannot substitute anything into anything. Okay. So how you supposed to combine cos theta with sin theta? Now there's this thing called trigonometric identities. Do you remember? Do you remember your trigonometric identities? Yes? No?
No.
No? Okay. Do you still remember all this?
Yes.
Trigonometric identities. Yeah. So these are, so what are trigonometric identities? Trigonometric identities are basically some common trigonometric rules, okay, that relate sine and cos or tangent together. Okay, so it's quite a big list. Okay, so you need to know how to use this. I think you must have learned this before. Okay, so you need to know how to use this table. But this one looks different from the one normally I use. Let me find the one that I normally use. this one, I think. Yeah, okay, we can use this one. Okay, so there. So these are some common trigonometric identities. So they are basically rules that link your trigonometric functions. For example, this one you must know lah. What is tangent? The first one. What is tangent theta? Tangent theta is sine theta over cos theta lah. Okay, you must know this. Cotangent is cos over sine. Okay, and then you have some common ones. Sine squared plus cos squared equals to 1. Okay, remember this one? Sine squared plus cos squared equals to 1. Remember this one?
Yes.
Okay. So you need to know how to use this. So in test and exam, this table will be provided to you. So you don't have to memorize. Okay. For test and exam, you don't have to memorize. The table will be provided, but it's not this table. It's another table. I cannot find the table here. I cannot find the exact table that I'm going to give you in test and exam. I think it's this one. Bukan. But the point is it will be given. Okay, so don't worry. The table will be given to you. You just need to know which identity you need to use, because as you can see, there's a lot. Yeah, as you can see, there's a lot. You need to know which one to use. Okay, but the table will be provided to you in test and exam. You don't have to memorize this. Okay, so you can solve this problem. So you can solve our problem using trigonometric identities. Okay. Now we have a cos, we have a sine. Which trigonometric identities has both cos and sine inside? I mentioned that one just now, actually. There's one that's cos squared theta. There's one that says cos squared theta plus sine squared theta equals to 1. Correct? There's one like this, right? Okay. So now basically what we have is we have a formula that relates cos and sine together now already. Okay. So what we need to do next is we need to substitute this in there. We need to substitute that in there. Then hopefully the theta hilang. Okay, our aim here is to lose the theta. Okay, so let's substitute. So cos theta is x over a. So if this one, then it's x over a lah. But don't forget squared. There's a squared there. Okay, and sine theta is y over a, and then don't forget your squared, and then both is equal to 1. Okay. Next, we simplify this. So x squared plus y squared equals to a squared. Agree? Agree, yeah?
Yes.
Okay, good. Okay. So now, what can you do? What basically next you can basically plot the shape now. You can basically plot the shape now. What shape do you think this is? What shape is this equation? So you know y equals to x squared is u. You know x equals to y squared is what? C kah? Yeah. So yang ini apa? So
Parabolic.
Yep. So y equals to x squared is u. X. So take a look. When you have x squared, you have half a circle. When you have y squared, you also have half a circle. Yeah. You see, x squared half a circle, y squared also half a circle. So now I have x squared plus y squared combined. What do you think it gives you? Half circle plus half circle. What do you get?
A ball and a
Yeah.
circle.
Correct. A full circle. So this here, if you don't believe me, this here is a formula for a circle. You can Google. You can go Google formula for a circle. That's basically what you can get. Okay. So this is a formula for a circle where A where A is radius of circle. Okay, so what that means is to plot this. So it's a circle where A is the radius. Okay, now we have A squared here. Okay, so what that means is if A is if A is the radius, that means it's like that. And then you just use a circle. Yeah, it's basically a circle. Like that. Okay. But our question is not finished. Our question is not finished. So now we basically okay, let's go back to the question. Why question not yet finished? Okay, what does the question say? Question says plot the function, show direction, show IP, show TP. So we plot the function sudah, but we never show the direction. We never show the starting point and ending point, IP and TP. So we haven't finished answering this question. So let's finish it. Okay. So next step, what do we do to show the direction as well as the starting point, ending point? So for that, we need to use the interval. Just now what did I say is the interval? Go back to the question. What's the interval? 0 and
Pi.
yeah, good, correct. Thank you. So basically what that means is so the interval always refers to the parameter. Okay, so what it means is the theta goes from 0 to pi. That's what it means. Not A, not A. It's the theta that goes from 0 to pi. Okay, so to get the starting point and the ending point, you plot here lah. You still need to plot a simple table. Okay, like the one we plot earlier. Except before we use t. Yeah, previously we used t to get x and y. In this case, our t is a theta. So we need to replace with a theta lah. Okay. So our t starts where? Sorry, our theta starts where? Starts 0 ma. So you put 0 there lah. So whatever x and y you get, you know it's the initial point. All right. Next, where does it end? Where does theta end? Where does theta end?
Pi.
Yeah, pi. So whatever x and y value you get, that is the terminal point. No? Yeah. So that's how you get initial points and terminal points. Initial and terminal points. Yeah. So now, can someone calculate x and y for me? So you put 0. So you put theta equals to 0 back into your this two. Yeah. So x is a cos theta. So if theta is 0, what do you get for x? Cos theta is what? Cos theta is what? 0 or 1? Sorry, cos 0. Cos 0. Cos 0. Cos 0 is 1. So 1 times a is what? A lo. Yeah. So x is a. Okay. Now, sine theta is what? Sine 0. Sine 0 is what? Okay. Right now theta is 0. So sine 0 is what?
0.
0. 0 times a. Yeah. There. Yeah. Sine 0 is sine 0 is 0. 0 times a. What do you get for y? 0 lah. 0. Okay. So next, theta. Cos theta is what? What is cos theta? 0 or 1?
-1.
Negative 1. So negative 1 times a. Negative.
A. Negative A.
Okay, good. Thank you. Okay, next, the last one. Okay, now I'm not gonna tell you how to find y. Can you get the y for me? This one. Calculate the y for me.
Zero.
Yeah, 0. Okay, good. Thank you. Okay, so So what you know now is initial point is a 0. Terminal point is negative a 0. Okay, so go back to your graph. Go back to this graph. Where is a 0? Sini makan. Agree?
A.
Yeah. So a0 is there. So that means that is your initial point. Next, where is the TP? TP is negative a0. Where is negative a0? There. So that is your terminal point. Okay. So now you have your initial points and terminal points. Can you find the direction? Okay, now you have another dilemma. Actually, you cannot find the direction yet, kan? Because from initial point to terminal point, you can either follow the circle at the top to get there, or you can either follow the circle at the top to get there, but you can also go the bottom way. Yeah, you can go up or go down. You can still go from IP to TP if you take either the top or bottom route. So which one is the real route? Which one? You guess, or can you make a decision? How do you decide which one? Okay, the way you decide is you go back to the table. You go back to the table. You find another point lah. You find another point in the middle. Okay, so our theta goes from 0 to pi. Can we choose a value in between? Well, what's a good value in between to try? You can use pi over 2 ma. Pi over 2 is in between ma. Kan?
Yes.
Yeah. Okay. So when theta is pi over 2, what is x? What is x?
0.
0. Yeah, very good. Thank you. Yeah. What about y?
1.
1. Yeah, well, not 1 kan. 1 times a, right? Yeah. There. Yeah. Yeah. Because sine pi over 2, sine pi over 2 is 1, correct? But you have an a in front. Don't worry. Don't forget. No, don't worry. Don't forget. Yeah. So 1 times a is a. Okay. So now you have a midpoint, which is, we know this is midpoint because pi over 2 is between 0 to pi, so it's midpoint. So we know we have a midpoint at 0 a. Okay. So let's go back to our graph again. So let's just go back to our curve again. Where is 0 a? Here, right? Agree?
Yes.
So you have a midpoint here. So now, do you know? So now, do you know whether these curves follow the green route or it follows the blue one? Which one is it? Green or blue? Green gun. Yeah, because you start at IP, you know the midpoint is 0a there, and then it terminates at negative a 0. Okay, so the half circle on the top is correct. So what that means is the bottom part, so it goes from IP to midpoint and stops there. So it doesn't continue anymore. So basically what it means is essentially the bottom part doesn't exist. You have to delete the bottom part. Okay. So that's your answer. Okay. That's your answer. Any questions, ladies and gentlemen? Any questions? Okay. No questions, huh?
No, doctor.
Okay. So let's do one more example, if everyone's happy. Okay. So x equals to 4 cos theta. Y equals to 3 sine theta. And the interval is from 0 to 2. Yes. So the intervals from 0 to 2 pi. Okay. So the instructions are the same. Plot function. Show plot function. Show direction. Show IP. Show TP. Okay. So same instructions. so how are you going to do this? So again, for this question, you can choose both methods. You can go method 1, which is the previous method. Okay, you use the identity to combine, and then you get your x and y function, and then you look at the function, you see what shape it is, then you draw the shape, and then you find the initial point, you find the ending point, and maybe a midpoint, and then that's it. Okay, or you can use method 2, which is you just plot a whole load of points, and then you join all the dots together. Okay, maybe we'll do both. Okay, we do the first one first. All right, so let's do the first method first. So x and y both have cos and sine in them. How do you combine both together? Okay, so this question is very similar to the previous one. Okay, I'm gonna just go through very quickly. Okay, if you don't understand, you let me know. All right, so we know x is equals to 4 cos theta. So you can rearrange to get cos theta. That means it's x over 4 lah. Okay, now we also know y is equals to 3 sine theta. If we rearrange to get sine theta, we get y over 3. Okay, so now you use identity. So this is a common identity. Cos squared plus sine squared equals to 1. Yeah, so we use it as identity. Cos squared theta plus sine squared theta is equals to 1. So we substitute this in there. We substitute that in there. We will get x over 4 squared plus x over 3 squared equals to 1. So we get x squared over 4 squared plus x squared over 3 squared equals to 1. So now you have the converted x and y function. What shape is this? Okay, this is a bit like a circle, but it's not a circle. What is a circle but not a circle? So
Oval.
yeah.
Oval.
Yeah, oval. Yeah, oval. Or we call it ellipse. Yeah, we call it ellipse. A circle is a perfectly round circle. Okay, yeah. So a circle is perfectly round. An ellipse is, like a flattened circle. Yeah. So an ellipse is when I demo here. Yeah. So ellipse is when okay. So an ellipse looks like that. So the ellipse is when the x-axis punya radius is different from the y-axis punya radius. Okay, one is longer than the other. So different radius. In x-axis, there's one radius. In y-axis, there's another radius. Okay, so that is ellipse. All right. So basically, in an elliptical function, that number at the bottom is the radius. Now listen carefully. Yeah, listen carefully. This one, I don't want you to make this mistake in test or exams. Okay. Maybe test or the exam. Okay. Now, if you pay attention, this 4 and this 3, I never do this. Hey, sorry, this one's supposed to be y. Yeah, this one. Wait, sorry, this one's supposed to be y. Okay, change. Y over 3, then y squared over 3 squared. Y, bukan x. I wrote x just now. Okay, supposed to be y. Okay. Okay, but the thing I want you to pay attention is the bottom part. I leave the power 2. Yeah, I left the power 2 there. I didn't find the final answer for the 4 squared and the 3 squared. Okay, I left the power 2 there. Why? Because the radius, the formula is the radius squared. Okay, it's radius squared. So if you convert this to 16, then you don't have the radius anymore, because the formula for ellipse is this. Okay, it's radius squared, radius squared. Then only you can draw your ellipse. If you change it to 16, you change it to 9, then you don't know what the radius is, sudah. Okay, so leave the squared in place. Okay, this is important. Leave that squared in place. So that means radius is 4. That radius is 3. Okay. So now let's draw your ellipse. So what we know then is, in the x-axis, the radius is 4. Lebih kurang macam, yeah, more or less like that. And but in the x-axis, the radius is only 3. Yeah. So your function looks like this. Not very nice. Wait, let me redraw. Okay, something like this. Okay. Okay, so an ellipse. All right. So next. So we plot the thing already. Let's go back here. So plot. Done. Next, we need direction. We need IP. We need TP. So again, same problem as the previous one. We need to know where is the starting point, where is the initial point, where is the terminal point, and which direction it goes. At the moment, we don't know. Yeah, so we need to plot 3 points lah. Plot 3 points. One for the IP, one for the TP, and maybe one midpoint, so that we know the direction. Okay, so theta X, and Y. So theta goes from where? Theta starts where? 0 kan? Tu. Theta goes from 0 to 2 pi. So we know theta starts its journey at so we know it starts its journey at theta is equals to 0. So that must be the IP. And we also know that it stops its journey at 2 pi. So that must be the TP. And then we choose somewhere in between lah as the midpoint. Which point do you want? Maybe I try pi lah, somewhere in the middle. Okay, pi. All right. So same thing. This one you work out for me. What is X and Y? When IP is 0, what is X and Y? Just tell me. Quick, you do it, and you let me know. Quick. When theta is 0, what is X, Y is Y?
X 4, Y 0.
X what?
X
4.
Oh.
Okay, 4. Y 0. Okay, very good. Okay, someone else for TP. What is the X and Y for TP?
4
Someone else?
0.
Okay, 4 0. And what is the midpoint?
-4 0.
Okay, so now we have IP, TP, and midpoint. Okay, thank you. Thanks for that. Okay, so now we have IP, TP, and midpoint. Now, you notice here, IP and TP, same point. Yeah? So both, that means it starts, it starts its journey here, and it finishes its journey at the same place where it started. Okay? So titik permulaan dan titik akhir tempat yang sama. Okay? 4 0. So now we need to know which direction it's going. So we know that halfway during the journey, at the so-called midpoint, it's at -4 0. So where is the midpoint? -4 0. So that is this is midpoint, right? Yeah, this is midpoint there. So we still have a problem. Okay, we have IP, TP. However, we still have a problem because so what this means is the movement is a full ellipse. The movement of this thing is a full ellipse. It starts and ends at the same point, but we don't know which direction it's going. Is it going counterclockwise, or is it going clockwise? We don't know. Yeah, I cannot tell. There's not enough information to tell. Huh? I cannot tell. So what that means is you need at least one more point. Okay, you need at least one more point. So let's try one more point. So let's try. So we know it goes from 0 to 2 pi. The midpoint is pi. So let's try a pi over 2. Let's try pi over 2. So pi over 2 means when it's 25%. Yeah? Yeah? 0 to 2 pi. When you are halfway, 50% throughout your journey. Yeah? Yeah? So 0 is when 0% mah. And as you go throughout the journey, when you finish the journey, you reach 2 pi. Okay, that's 100%. That means your journey finished lah. Okay. Now the midpoint, when you're 50% through your journey, okay, it's it's pi mah. Okay. So let's choose something somewhere there lah. Okay, 25%. It's pi over 2. Okay. So when it's pi over 2, what is x and y? Just put the numbers in. Give me x and y. Well, I can tell you it's 0, 3. Okay. You can do it on your calculator, but when it's 25% through, it's 0, 3. Where is 0, 3? It's there, ma. It's there. Okay. So now do you know the direction? It must be this one. So you start at IP, you go there. So it must be the counterclockwise. Okay. It must be the counterclockwise version. Okay. Giving you a full ellipse. Any questions? So now you have all the information that I asked for. I asked for the function. I asked you to plot a function. I asked for IP. I asked for TP, and I asked for direction. Okay. So it's only when you give me all this information that you can get full marks. All right. So this is method 1. This is method 1. Now we also have a method 2. You know how to solve this using method 2? Basically, you draw the table. 0, theta. Okay, you draw a table, theta, x and y, and you plot in a lot of points. 0, pi over 3, pi over 2, then all the points in the middle, I don't know lah. Yeah, then pi, then I don't know. 2, 3 over pi, then blah, 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 until you get 2 pi. So you need a lot of points. I don't know, maybe 20 points. Okay. Then once you get all these points, then on your x and y, you plot the points lah. Maybe the first point is there, maybe second point is there, maybe third point is there, maybe fourth point is there, maybe fifth is there, maybe sixth is there. Yeah. According to all these points, you can plot all the points. Then you join all the points together. You will also get the same answer. This is method number 2. Okay. So you can use whichever method you want. Okay. Okay.
Okay, doctor.
Right. Okay. Okay. Next. Next. One more example. Wait.
There's an interesting example. Okay, let's do this one. All right. Okay, I found one. Right. Okay. So x is equals to sine t. Y is equals to sine 2t. The interval is 0 to 2 theta. So in this case, I replace theta with t. Okay, but it's still the same lah. It's trigonometry. Okay, theta. So t goes from 0 to 2 pi. Okay. So my instructions is to convert to Cartesian function, then plot show direction, show initial point and terminal point. Okay, so for this question, I'm not giving you a choice. Right? This question, I'm not giving you a choice. I basically ask you to plot the function. To convert. So you have to use method 1. Okay. So here I'm basically forcing you to use method 1 because I'm asking you to convert first. Okay. So how you gonna convert x equals to sine t, y equals to sine 2t into a Cartesian function where no more t. So basically when I say convert, means I want you to combine x and y together and remove the common parameter. So remove the common parameter t. That's basically what I mean. So how do you do it? So again, you need to use identity. All right, use identity. So what identity can I use? So you need to choose an identity. You need to choose an identity that has a sign 2. Yeah. So you need to choose an identity that has a sign t and a sign 2t. So let's go to our list. Which one has sin t and sin 2t? This one macam dia tiada. This is not a full list. Let me get a full list. Okay. This also don't have. Wait. And this one doesn't want to load. This one
Hey, how come all don't have? There is one, but I cannot find it. You need one that has sine t and sine 2t. Ah, ada. Dah. Let me zoom in. I cannot zoom in. Do you see here? Sine 2a equals to 2 sine a and cos a. You see this one? The one in the middle.
Yes.
2a equals to 2 sine a cos a. The a is basically t or theta lah. Okay. Sine, apa dia tadi? Sine 2a ke? Yeah, sine 2a equals to what? 2 sine a cos a. Yeah. I just copied directly from the identity just now. Okay. So a is basically t lah. So you can rewrite sine 2t equals to 2 sine t cos t. Okay. The important point is this. Important point is I managed to find a identity that relates sine 2t with sine t. Yeah, I managed to find one that relates these two because in my question, I'm trying to combine sine t with sine 2t. But I want to combine both together. So then that means I need to find an identity that has both of them in there lah. Yeah. Okay, so now that I've done that, can I substitute in? Yeah, I can. So sine 2t is what? Sine 2t is y, ma. Yeah, sine 2t is y. But the problem is there's another small problem. Okay, because you have a sine 2t. Okay. Now normally in calculus, okay. So normally in calculus, whenever you have this 2t, it's very difficult to work with. Okay. Normally when you have 2t ka or 2 theta ka, okay. This type of situation is very difficult to work with. Okay. Give me a second. Okay, so instead of substituting it straight away, you can do it that way, but I'm gonna go a slightly different route. Okay, I'm gonna go slightly different route. Okay, you can substitute straight in. Okay, but I'm gonna do it a slightly different method. Okay, so what I know is my y is equals to my y is equals to sine 2t. Okay, so in the question, so in the identity, I also know that sine 2t, yeah, I know sine 2t is equals to this. So I can substitute this into sine 2t. So my y is equals to 2 sine t cos t. Okay. So now I know.
sine t x is equals to sine t, ma. Yeah. So then I can replace sine t with x. So it's 2x cos t. Okay. So have you finished? No, you haven't finished. Why? You haven't finished. Why? Because you still have a t here. Yeah, your t remains. You still have one more t. You don't want any t at all. You want to combine x and y and remove the t. The t is still there's still one t there. So you haven't solved the problem. Okay. How do you remove that cos t? How do you remove that cos t? Anyone? How do you remove the cos t? You still have a cos t there. How do you remove that one? Any ideas? Okay, so let's rearrange. Let's rearrange to isolate the cos t on one side. Okay, at the moment it's all mixed together. X, y, t, all mixed together. We isolate t. We bring t to one side. I cannot spell isolate. We isolate our t. So bring it to one side. So cos t is what? Just rearrange. Y over 2x kan. I'm just rearranging everything, yeah? I'm not doing anything funny. Okay, I bring cos t to one side. So you know y is equals to so you know cos t is equals to y over 2x. Okay, so let's make let's make this equation one. Now, okay. Now, you also know from the question is x is equals to sine t. Kan? What that means is sine t is equals to x. Yeah. So that's equation 2. All right. Now you have cos t, you have sine t. What identity can combine these two together? So you want an identity that can combine these two together again. Which one? Sine and cos. The one we did previously in the question. Which one? Yeah, correct. Very good. Thank you. This cos squared theta plus sine squared theta equals to 1. Except now it's t lah, bukan theta. Yeah. There. Cos squared t plus sine squared t is equals to 1. We can use this identity to combine the two. Yeah, because you have cos t, sine t ma. Yeah. So then you substitute lah. Equation 1. You put in, let me use green color better. Because the background is blue as well. This one in there, that one, there. That one in there. So you get this squared plus that squared. The whole thing is equals to 1. So now, problem solved. Problem solved sudah. You can see no more t. Tiada t sudah. So I solved the problem. So now you just have to guess. Sorry. We haven't solved the problem. We solved one problem. Which is no more t. Okay. So we solved one problem, but we have another problem now. What shape is this?
we solve one problem, but we end up with another problem. What shape is this? Yeah, I don't know. Yeah, I don't know. But kita hantam saja lah. Okay, we keep going first. Maybe we get lucky and we can see something out of this. Okay, at the moment I don't know. Okay, so okay, y squared equals to what? 4x squared plus x squared equals to 1. Okay, what shape is this? I don't know. I still don't know what shape is this. Never mind, let's continue. Okay, so let's direct let's take the 4x squared up, okay? Or sorry, or rather, we remove the denominator, okay? Yeah, for the 4x squared. So if I remove it, then I get what? Y squared plus 4x to the power 4 plus 4x squared. Rearrange everything, I get 4x to the power 4 minus 4x squared plus y squared equals 0. What is this? So now we finish converting, okay? Okay, we finish converting. But what shape is this? I don't know. I don't know. Who knows what shape is this? You tell me what shape is this? I let you pass calculus straight away. You don't have to sit any test or exam. What shape is this? You give me the answer, I pass your calculus straight away. You get A. You don't have to attend tests. You don't have to attend exams. Anyone? Don't know, kan? Very complicated, right? Okay, so when you have the so now we finish converting. Okay, so now we finish converting. Okay, there's actually only one. If you don't know the shape, okay, if you don't know the shape, there's actually not much you can do. All you can do now is you go for the table method. Sorry, you go for the table method. If you cannot guess the shape at all, you go for the table method. T, yeah, T, and then X1. Okay. You just have to draw the entire table lah. Okay, so the T starts where? 0 kan? Yeah. So that's the IP. Okay. So you plot all your points all the way to the TP. Then you're gonna get a shape. Okay, yeah. Anyone there? Are you still there? Yo, you still there?
Yes, doctor.
Okay. All right. So if you cannot guess the shape, then susah lah. You just have to plot. You just have to make sure you plot enough points so that you get an accurate shape. Okay. However, there is something I can teach you to help you solve it. Make your life a bit easier. Okay. There's something I can teach you here to make your life a little bit easier. Okay, which is this. Okay, let me go through it. I also forgot what I said last time. Let me go through my notes. Okay. So there is this rule. So at the moment you have to plot the whole thing. Okay, it's very suffering. Okay, because we cannot guess what shape this is. So we have to plot everything. But if you know certain rules in calculus, you can save yourself some time. Okay. So what rule is that? So the rule is this.
The rule is this. Every time you have a even power, okay, so the rule is this. So it's actually about even power, not odd power, not odd power. Even power rule. Even power means squared ka, power 4 ka, power 6 ka, things like that. Okay. So I'm not talking about odd power. If it's odd power, you cannot use this. Odd power means x ka, so x to the power 1, yeah. Power 3, power 5. Okay. If it's this power, you cannot use this rule. It's only when it's even power you can use this rule. Okay. So I'll show you what this rule is about. Okay. Now, have you noticed something? When x is equals to when y is equals to x squared, what is the shape again? U, right? U kan? Yeah. Now this U is mirrored left and right. So so if you look at y-axis, if you look at your y-axis, whatever you have on the left side of the y-axis is mirrored on the right side of the y-axis, correct? Correct? Yeah. So whenever you have x squared, whenever you have x to the power 4, or doesn't matter. It can be x to the power 2, x to the power 4, x to the power 6, whatever. Whenever you have even powered numbers, whatever happens on left hand side happens on right hand side. Okay, it's the same here. Now I give you an example. X is equals to y squared. Now x is equals to y squared. Everyone knows, even babies, they know it's, what shape is this? What shape is this? X equals to y squared is what shape? C kan? Agree?
Yeah.
Yes.
C. Now, when you have C, whatever is happening on the top of x-axis is exactly mirrored at the bottom kan? Yes or no? Yeah. Whatever shape you have at the top is mirrored at the bottom. Yeah. So when you have y squared, everything on top of x-axis is mirrored to the bottom of y-axis. When you have, yeah, so that's when you have y squared. When you have x squared, everything on the left of y-axis is mirrored on the right of y-axis. Do you see this relationship? You see this relationship?
Yes.
Okay. Now, so we are going to apply this relationship to our problem to solve, to reduce our workload. Okay, it's not a magic trick. It's not like you can guess the shapes. No, you cannot guess the shape, but it will reduce your work burden. Okay, it will reduce your work burden. Let me remove this first. You remember this? You remember this rule for the rest of your life? How come can I delete? Oh no, what happened? Have to erase again. Just now, the app crashed just now. Okay, so remember this rule. So let's go back to our equation. Okay. So if you didn't know that rule just now, what you're gonna end up doing is you have to plot all the points from 0, all the points to pi. And you need a lot of points. You need a lot of points in the middle to get a decent shape. Okay, so a lot of work lah. Okay, now, but if you study our equation, If you study our equation, now we have x even power. We also have y even power. Yeah. So in our equation, we have x even power. We also have y even power. All right. So let me write this down. So in our equation right now, we have x, which is even powered, and y also even powered. Okay. So what that means is, if you try to remember, go back to the rule that I talked about just now. What this is basically telling you is, for this function, whatever shape you have on, so let's look at the x even powered first. Just now, x even power is what? Y equals to x squared. Okay, y equals to x squared is u kan. Okay, so when x is even powered, it's mirrored left and right. Okay, all right. So x even powered, what that means is, whatever shape you have on the left or on the right, it will be mirrored. Okay, it's mirrored left and right. Okay, for x even powered. Okay, next we also have y even powered. What y even powered means is, whatever shape you have on top, you get the same shape at the bottom. It's mirrored top and bottom. So one of them, x squared, is mirrored left and right. Y squared is mirrored top and bottom. Do you see where I'm getting at now? What I'm trying to get to? So what I'm trying to get to is actually, because we have x squared and y squared, basically everything is going to end up getting mirrored. Basically what it means is, you just have to find the points in one quadrant. So you just have to find from 0 to 90 degrees saja. You have to find what is happening in one quadrant saja. 0 to 90 degrees. Whatever shape you get here, it will get mirrored there. It will get mirrored there. It will get mirrored there. That's basically what's happening. Yeah, because you mirror, because you have x squared and y squared, so you can mirror top and bottom, left and right. So the reason why this rule will help you save time is, now instead of plotting 0 to 360 degrees, you only have to plot 0 to 90 degrees. So go back to the table. You plot 0 to 90 degrees, which is a lot less work. 90 degrees is what? Pi over 2 kan? Yeah, pi over 2. Okay, so you choose some more points in the middle lah. I don't know. Pi over 6 ka, pi over 4 ka, then pi over 3 ka, then pi over 2. Okay, so you just have to plot these 2 points. Faham ka? Okay, you plot these points on your own. You tell me what is the shape. I give you 5 minutes. Find the x and y. 5 minutes, find the x and y, and then plot the shape. Plot the shape from 0 to 90 degrees. I give you 5 minutes. Okay. In the meantime, I will share the attendance link as well. Okay. All right, 5 minutes. Plot the shape. to log into this chat, and I have shared the attendance link. Did you see it in the messaging box? Yeah. Okay. So do the attendance now. Do the attendance now. It will expire at 11 o'clock. Okay. So you have 1 hour 20 minutes to do it. To attend the attendance, but do it now, lah. Do it now. Okay. All right. I'll give you 3 minutes I'll give you 3 minutes to do it. We'll continue with the question at 9:40. Yeah, at 9:40 or 9:41. Okay. 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 Did you get the shape? Did you get the shape? What shape is it? Anyone? What shape is it?
Like butterfly wings.
Yeah, correct. Yeah. From its starting. So the starting point is what? 0, 0, 0 kan?
Yes.
Yeah. Yeah. So the IP is 0, 0. So it starts at the 0, 0 lah. Okay. Next point. When pi over 6, it's half and square root over 2 kan? So it's there. Next point is somewhere, I don't know, there. The third point is up there. Next point, it comes down here. And then the fifth point, when it's pi over 2, it's somewhere there. Okay, so it's like that. Okay, but this is 0 to pi over 2 only. Okay, what about from pi over 2 to pi? What do you think it does? Okay, you can continue plotting. But we know whatever this shape is, it's gonna mirror at the bottom. So you know the line does this. It goes up, it comes down, then it has to continue. Yes, continue. Yeah, when it reaches 0.5, yes, continue. It can only continue one direction. Yeah, you cannot suddenly start there, ma. Okay, it can only continue one direction. That means this line will continue the same shape here. Sorry, my hand's shaking just now. So it can only continue the same shape here. So this is from pi over 2 to pi. If you don't believe, never mind. In this table, you can continue plotting all the way to pi. You find the points. You will see that the points are here. Okay. Next, you stop here, but this is only to until pi. In the question, I asked you to look for 0 to 2 pi. So you have to keep continue. So if you draw one, so if you notice, every quadrant we cover 90 degrees. So here we have another 90 degrees. So we need another 90 degrees somewhere here, so that we cover a full 2 pi. Okay, at the moment we only have pi over 2, another pi over 2. So only 3 pi over 2. We need 4 pi over 2s. So it's going to do this over here. And finally, it's going to do the fourth circle over there to finish. So then when it finishes, you can see it finishes at the same point there. So that means the IP and the TP is actually the same point. And then I also have my direction sudah. Yeah. So yeah, it looks like butterfly wing lah. Yeah. Yeah. So you can use this table to plot all the way to 2 pi. You will get this shape, or you can plot it from 0 to pi over 2. You get the shape for one quadrant, and then because you know it will mirror top and bottom, left and right, so you just draw the same shape, top and bottom, left and right. You get the same answer. You get the same answer. Okay, understand? So you can do either way. You can either plot from 0 to 2 pi, or you can plot from 0 to pi over 2, and then you mirror up and down, left and right. Okay, to get the same answer. Okay, because why? Because up and down, because we have y squared. Okay, because we have x. Up and down is y squared, because we have even power y squared, and left and right because we have even powered x squared. Or is it the other way around? Left and sorry, left. Yeah, betul. Yeah. Yeah. Okay, any questions? Any questions? Okay. All right. Okay. So thanks for replying. At least someone's talking to me. I don't know what the rest are doing. What's your name? Adam, huh? Okay, thank you. Thank you, Adam. Okay. Okay. So right. So if there are no questions, I will see you on Friday lah. Friday. Can you move the class earlier, kah? Are you able to move the class to the morning? Are you free in the morning? Morning. What time are you guys free? Oh, why? What? Oh, oh, but only week 1 to week 3 lah. After that, what time is the class? Okay, to 10. So you will be free from 10 to 12 lah. For the whole semester. Oh, okay. What about 10 to 12? Do we have other class? Then can I move calculus to 10 to 12? Okay. Nanti I put it to a vote lah, because I think you prefer morning juga kan. Then afternoon after prayers, I think you want to go rest kan. Yeah, okay. Later we do a vote. Can you help me do a vote? Whether they want to stick to the time, to the old time, or whether they want to move it to 10 to 12. Obviously 10 to 12 I will stop earlier lah, because I know you have to go for prayers. So it's actually 10 to 11:30 lah. Okay. So see whether you guys okay or not. Can you help me do a poll later? The class rep. Yeah. Okay. All right. So I'll see you Friday. Online. The time to be confirmed. Okay. Okay. Thanks. Okay. Don't forget do the attendance. All right. See you everyone. Bye.
You, Doctor.
Okay, Doctor.
Thank you, Doctor.
Uh,